Welcome, Hornets. In this portion of our video, we're going to be taking a look at the special limit and why. Why is the limit as x approaches 0 for the sine of x over x equal to 1? Now, in order for us to do this, we're going to have to use what is called the squeeze theorem. Now, I'm never going to ask you to do the squeeze theorem on your own, but I'm going to show you how to do it right now. Okay? So the whole idea behind this problem is that if I look at just the first quadrant of the unit circle, I have my tangent line going up, and where I create an angle, you'll notice that I have the area of a sector, and I have a larger triangle. Let's just draw that right down below. So here we have our large triangle, and this point right here is 1 comma tangent theta. This point is 1, 0. And because this is a vertical line, this height is the tangent of theta and corresponds to our y value in the point. So we now know that this is a length of 1 and this is a height of tangent of theta. Now, my goal is to work with the area of this, and the area for this triangle is 1/2 tangent theta. Now you'll notice that there's an arc. That arc right here is next. And the arc has an angle. And the area of this sector is theta divided by 2. The third piece that we're going to find is the triangle sitting right inside. Now this point right here is cosine of theta, sine of theta, and my height is therefore the sine of theta. So I'm going to be using my length of 1, my height of sine of theta, and you'll notice that I get the area of this triangle as 1/2 sine theta. Now everything else is going to be a manipulation, and at the very end we're going to apply our limit. So let's just take a look at how do we manipulate this. You'll notice I can get rid of a 2, so I'm going to multiply everything by 2. I end up with tangent, which I'm going to now rewrite as sine theta over cosine theta, is greater than or equal to just theta, which is greater than or equal to just the sine of theta. I'm now going to multiply by the sine 1 over the sine of theta. Now all I'm doing is manipulating the algebra here in order to clean this up. You'll notice that by doing this I get 1 over cosine of theta is greater than or equal to theta divided by the sine of theta, which is greater than or equal to 1. Now watch what's going to happen here. I'm going to take the reciprocal of everything. Now remember, when we take the reciprocal, we are going to flip our inequality. So the fraction that we have as 1 over cosine becomes the cosine of theta, and that is now less than or equal to the sine of theta over theta, which is less than or equal to 1. I'm now going to apply my limit. I'm going to take my limit as theta approaches 0. So you'll notice in this picture, this side is moving down and our angle is getting smaller. That's what's creating the squeeze theorem. The smaller that we get for our angle, the closer all three pieces, the arc and the big triangle, and then the little triangle, which had the height of the sine of theta. So our height here was the sine of theta with a length of 1. Now, it's at this point when we take that limit, let's just look at what happens. The limit as theta approaches 0 for cosine of theta is our transcendental function. 0 is on our domain, so we can plug it in. The limit as theta approaches 0 is the one we're trying to figure out. We don't know what that is yet. And we have the limit as theta approaches 0 for a constant 1. Well, let's do our transcendental. What is the cosine of 0? 1. Now look what just happened. We have just bounded the two endpoints by 1, which means that if 1 is less than or equal to the limit as theta approaches 0 for the sine of theta over 0, and the limit as theta approaches 0 for sine of theta over theta is less than 1, the only possibility is that it has to equal 1. Therefore, the limit as theta approaches 0 for the sine of theta over theta equals 1. And that's how we know. It's based upon this idea that as this angle goes down, the area of the sector, the smaller triangle and the larger triangle, all approach the same value. By taking our limit of theta right here for these three pieces, we are doing what is called the squeeze theorem, and we've squeezed this answer in between the same thing, which means if it's less than 1, or if it's greater than 1 but less than 1, it has to equal 1. And that's how we found it. Thank you very much. That was how we figured out the limits for those three special limits. Next, I'll be showing you how to use those special limits. Thank you very much.